Bismillahirrahmanirrahim. As I suggested in last time, now we're talking about perpendicular lines and the theorems that are related to perpendicular lines. Specifically, we shall talk about 5 theorems that are related to perpendicular lines. Last time we talked about one of them, and that was related to the linear pair. And we had suggested if two lines intersect to form congruent linear pairs, and then those lines were perpendicular. So that was the linear pair congruence theorem. There are 3 additional ones. Here I shall mention, inshallah, 2 of them. And these are reasonably basic intuitive theorems, so I shall not elaborate too much on them presently, inshallah. But we shall talk about them in the future again. So the next theorem is basic and very important, and we shall write the skeleton of our conditional statement there. So the first theorem says if 2 lines, okay, so if 2 lines are perpendicular, okay, if 2 lines are perpendicular, so as we can call this L and M again, such as L is perpendicular to M, for example. If 2 lines are perpendicular, then, okay, then they intersect to form, okay, 4 right angles. I'm going to spell it out. Right angles. Okay, that is like this. They intersect to form 4 right angles. Okay, notice that's a symbol for perpendicularity. That's a symbol for right angles. Okay, so now this theorem seems pretty intuitive, right? What it's trying to emphasize is the 4. If 2 lines are perpendicular, they form 1 right angle, yes. But what it's trying to suggest is the 4 angles that are formed, all of them are right angles. Okay, by necessity, all of them are right angles. That's reasonably easy to appreciate. You think, okay, for example, these are vertical angles, right? We've done that, and since these are linear pair, they're supplementary. Those are right angles, and that is vertical angles. So it's reasonably easy proof if you can see that, okay? But the emphasis here is on the 4. So if 2 lines are perpendicular, then they intersect to form 4 right angles, because it's very useful, because sometimes in questions, for example, you add an additional angle, and then things get pretty complicated after that, and if you have another angle like this, okay? So, but the idea here is if you have 2 angles that are perpendicular, they give you 4 right angles to work with. Okay, that's a very important theorem to appreciate. Now this one over here, this theorem is about adjacent angles. Okay, if you have okay, so these angle 1 and angle 2 are adjacent angles. So if you recall, adjacent angles, okay, adjacent angles have 2 sides. Okay, they have one side that is shared between them. That's called the common side. That's the shared side. So that is the shared, okay, shared side. Okay, that this side, this ray is common to both of them. And then they have a non-shared side, right? That's this. Okay, so let's make that big too. Why should we not make that one big? So those are the non-shared side, correct? Okay. So now, so this theorem says, okay, if 2, well, it's going to be non-shared side, right? Non-shared. If 2 sides of adjacent angles, okay, are perpendicular. In other words, this theorem is about the yellow lines. If this side and this side, if they are perpendicular, if 2 sides, okay, now obviously it's going to be the non-shared sides that are going to be perpendicular. How's the shared side going to be perpendicular, right? So I just put the non-shared part of it just to emphasis so for the present so that you understand. So if 2 sides of adjacent angles are perpendicular, then the angles are complementary. Complementary, my dear Watson, complementary. Okay, so this theorem is about two adjacent angles. The theorem is about adjacent angles whose non-shared sides, whose sides are perpendicular. If two non-shared sides are perpendicular, for example, I'll give you another example where they are not. Okay, so here's adjacent angles whose non-shared sides are not perpendicular, at least not in the picture. I can make them 15 and 20. Go, here we go. So then they're not perpendicular, so they're not going to be complementary. But if you were told that the non-shared sides are perpendicular, so if you were told that they were more like this, okay, and I said this is perpendicular to this, then they're complementary, and that's reasonable enough, right? Because then you can say that, you know, if they are perpendicular, then that's 90 degrees, okay, right? And then since the 90 degrees, angle 1 plus angle 2 must add up to 90 degrees. Why? Two baby angle give you one big angle, right? Angle addition postulate, right? And then you can prove that. So this is proof. If two sides of adjacent angles are perpendicular, then the angles are complementary. So this is about a special case of adjacent angles where you can prove them to be complementary. It's important, no fool, because we have to use this in doing some of the questions on exams, etc. But this is intuitive, I think, and if you get opportunity, you should try to write the proofs for these yourself. So here I elucidate for you two theorems that we learned in addition to the one that we've learned before. Previously, we had learned that if two lines intersect to form a congruent linear pair, then they are perpendicular. It's a linear pair congruence theorem. And then we learned that if two lines are perpendicular, then they give you not one but four. Then they intersect to form 4 right angles. And if two sides of adjacent angles are perpendicular, then they are complementary. As that is elementary, my dear Watson. Until next time, Assalamu alaikum.